Pradhan Shakil from the Republic 2.0, and in the last video of this paper, we've discussed the first 4 questions of Edexcel May 2025 exam. So now we'll start the questions from the question number 5. And the question number 5 is, you've got this question number 5. The line L1 has equation x minus 2y plus 25. The L2 passes through the origin and is perpendicular to L1. So if it is perpendicular to L1, the slope of L2 should be the negative reciprocal, and we've already got the point, which is the origin. So I'll just write this equation in y is equals to mx plus c form. So to write this equation in y is equals to mx plus c form, we've got x plus 25 is equals to 2y. So y comes out to be 1 by 2x plus 25 divided by 2. That is the value of y. Once you've got y, you've got the gradient of over here, and that comes out to be 1 by 2. You've got this m, and that is equal to 1 by 2. But the slope of L2 is going to be the negative reciprocal, which has to be negative 2. So you've got the slope, and now you can easily get the equation by using this form. Y minus y1 is equals to m times x minus x1. Since it is passing through the origin, so y take away 0 is equals to negative 2 times x minus 0. So you comes out to be y is equals to negative 2x. That is how you'll get the equation of L2. Once we've got the equation of L2, in the B part, he's telling us that L1 and L2 intersect at the point P. Use algebra to find the coordinates of P. So we just need to simultaneously solve the equations. And the equations are this one, which is L1, this is which is L2. I'm just going to equate them, and I've got negative 2x is equals to 1 by 2x plus 25 divided by 2, right? I'm just going to solve this equation to get myself the value of x. So negative 2x is equals to 2x plus 25. I'm going to multiply 2 on both the sides. So I must be having negative 4x equals to x plus 25. And then you must be having negative 4x, negative x equals to 25. And from here onwards, negative 5x should be equal to 25. And x would be equal to 25 divided by negative 5, which comes out to be negative 5. So that is how we'll get the value of x. And once we've got the value of x, we can easily get the value of y as well by plugging this value of x into this equation. So you must be having y is equals to negative 2 times negative 5, which comes out to be 10. So that is how you'll get the value of y. So you've got x and you've got y. So you've got the point as well, and that is negative 5 and 10, which is the point of intersection. In the C part, hence, find the shortest distance from L2 to the origin and write your answer in a fully simplified set. So we need to find the shortest distance, and one should know that the shortest distance has to be the perpendicular distance between the two lines. So first of all, for a better understanding, I'll somehow plot the equations. The first equation was y is equals to 1 by 2x plus 25 upon 2. So the x-intercept of this equation is going to be something like, negative 25, something like that. And the y-intercept has to be 25, yani 12 upon 5. 12 upon 5. So this equation must be somehow looking like this. Now the other equation is y is equals to negative 2x. So it must be perpendicular to this one, somehow like this. So this point of intersection, which is a common point of both the L2 and L1, and that was negative 5 and 10. We just need to calculate the distance of negative 5 and this point from all these things, and that is 0 and 0. So OA, right? So we just need to calculate the distance from OA. So OA is going to be x2 minus x1 ka square plus y2 minus y1 ka square We just need to calculate their distances. So I've got -5, -0 ka square plus 10 minus 0 ka square. So OA comes out to be -5, yani 25, 10 ka square, that is 100. So OA comes out to be root of 125. If you want to simplify it further, you can write it like root of 5 times 25, which is basically root of 5 times 5. And that comes out to be 5 root of 5. So that is how we're going to talk about this question. Now we've got the next question. And that is that we've got this area. The shaded area in the figure 2 shows a plan view of helicopter landing pad. The area consists of a major sector AOB, a circle O joined to a triangle AOC. Given that AO, and OB is 15 meters, so this is 15 meters, and you can see this is 15 meters as well. Apart from that, BC, this is 2 meters, right? CBO is a straight line, and the angle ACO, is 0.6 radians. Now, right after this thing, you've got the angle as 0.6 here. Show that the angle COA is 1.847 radians to 3 decimal places, right? So how would you do this question? You just need to calculate the angle over here, COA, the angle over here. So you can just simply apply the sine rule over here. You need to look for this angle theta. You need to find out this theta. You've got this 0.6. You've got the length of this side as well, and that is somehow 17. You've got the length of this side as well, and that is 15. And you've got the angle, which is 0.6 as well. So you've got all these angles. The 0.6, the opposite side of 0.6 is 15. And the opposite side of 17 is this angle. So first of all, you'll calculate this angle, which is alpha, and then you'll get the angle at O as well by just taking away both these angles from 180. So what you're going to do now, you just need to apply the sine rule. That has to be 0.6 divided by sine 15. Sorry, yeah. You've got the side 15 divided by sine 0.6 is equals to this side, which is 17. 17 divided by sine alpha. And you can easily get alpha from here as alpha is equals to, sine alpha is equals to 17 times sine 0.6 divided by 15. Whatever answer you get for this expression, your alpha has to be the sine inverse of 17 times sine 0.6 divided by 15. That is how you'll get alpha. And once you have got alpha, you just need to, for theta, theta must be equal to pi minus 0.6 and whatever value of alpha you get. And whenever you're going to take them away, you must be having the angle over here that should be 1.847. So the angle over here has to be 1.847. So by having this angle, we've got the opposite angle as well, right? This one, by just taking it away from 2 pi. So this angle must be 2 pi negative 1.847, whatever it comes out to be. So after this thing, we need to find out the total area of the landing pad. How can you get the total area? In the B part, the total area would be the sum of the area of the triangle and the area of sector. How would you calculate the area of triangle? 1 by 2 sides. You've got 17 and 15. 17 times 15, and the angle between them is sine 1.847 plus. Now, if you want to calculate the angle of the sector, you must just be using 1 by 2 r squared theta. The radius of the circle is 15 square, and the theta is going to be 2 pi, take away 1.847. You just need to add them up, and you'll get the area of sector, right, in the B part. Now, if you're looking into the C part, find the perimeter of the helicopter landing pad. We need to find the perimeter. And how can we find the perimeter? We need to have this side, and we need to have the arc length of this circle, and this side is already given, that is 2. So how could you easily get that? You've got AC, right? You've got AC, and that AC comes out to be something like, you can just simply use the cosine rule over here. AC can be the B square. B square is equals to A square plus C square minus 2AC sine the opposite of 1.847, right? So we just need to plug their values in, right? And you've got B square is equals to A, that is the 15, and this side, which is going to be 17. So 15 square plus 17 square minus 2 times 50 times 17 times 1.847. By sorting this thing down, you'll get B. And to have this angle, you can use L is equals to R theta. So the perimeter is going to be 2 plus the side that we had, the B square, the B, and the B is going to be the square root of 15 square plus 17 square minus 2 times 15 times 17 times sine of the angle in between them, that is 1.847, right? And then we need to add it into, you've got this side, you've got this 2 as well, and now the other side, the last, that has to be r theta. Radius was 15 and the theta was 2 pi minus 8.47. You just need to do the calculations and you'll get the perimeter. So that is how we're going to solve this question, right? Now, almost half of this paper, right, up till, we've done almost half of this paper up till question number 6, and we'll get to question number 7 in the next part of this video. Thank you very much.